Okay. So what we're looking at today is geometric series. So when we were looking at an arithmetic series is the sum of an arithmetic sequence. A geometric series then is the sum of a geometric sequence. So if 2, 4, 8, 16 is the sequence, 2 plus 4 plus 8 plus 16 is the series. So if we look at the formula for the sum of a geometric series, if we look at the sum in general, which is going to be the first term plus the second term, which is a times the common ratio, plus the third term, on and on and on. If we took that sum and multiplied everything by r, then I would get this. So I'd start with a times r squared. That would be multiplying this term by r, etc. So then if I subtracted the two lines, if I subtracted this line from this line, all of these would cancel out with the exception of this last term, which is a times r to the power of n, minus a. You have to imagine these two lines being flipped. So it'd be this minus this, this minus this, this minus this, all the way down. So then from this statement here, I have an s of n that is common to each term, so I can factor it out. Leaves me with an r minus 1. I have an a that's common with these two terms, so I can pull it out, and it gives me r to the power of n minus 1. To get s of n by itself, I divide both sides by r minus 1, and I end up with this formula. Again, a reminder, a is also the first term, so I could have the formula t of 1 instead of a. And then the condition is that r, the common ratio, cannot be equal to 1. Because if the common ratio is equal to 1, I'd end up with a 0 on the bottom, which I can't divide by. So we have 4 unknown values, a, r, n, and s of n. If we have 3 of those values, we can use the formula. So we need to have at least 3 of those values, and then we can find the 4th unknown. When the number of terms in the geometric series is not known, but the last term is known, another formula for the sum can be found by replacing the a times r to the power of n minus 1 by t of n. That was this part right here. So if r, sorry, not that part, this part in the formula. I can replace it with t of n, and I get this formula. So I can take r times the last term minus the first term divided by r minus 1. When r is equal to 1, or the common ratio is equal to 1, I have the first term plus that term every single time, because if its common ratio is 1, a times 1 is going to be a times 1 is going to be a. So I will get however many a's that I need for the sum of the series, and then I'll just get n times a. We don't generally see series like this. If I'm going to give you a series, I'm going to give you something to work with. So it says, show how the formula r times t of n minus a divided by r minus 1 can be developed from the first formula. So if I take this formula, what I want to remember is that t of n is equal to a times r to the power of n minus 1. So if I can somehow have this in my formula, I can replace it with a t of n. So the first thing is to remove the brackets. Then from here, if I take out an r, so if I divide r to the power of n by r, I would be left with an n minus 1. So if this was r to the power of 7 and I took an r out, I'd be left with r to the power of 6. Does that make sense? There's my t of n. So now instead of writing all of this, I can write my T of n minus A divided by R minus 1. So really, it'll just depend what you're given for unknown values as to which formula you should use. So class example number 2 says determine the sum of the first 15 terms of the sequence. So if I'm determining the sum, I'm trying to find S of 15, which means n would be equal to 15. Do I know what A is, or the first term? A is -5. Do I know what the common ratio is, what R is? -2. So S of n equals my formula A times R to the power of n minus 1 divided by R minus 1. So it'd be -5 times -2 to the power of 15 minus 1 divided by -2 minus 1. So I'll let you calculate that and tell me what you get for an answer. Yep. So -54,615 would be the sum of those first 15 terms. If I look at class example number 3, it says determine the sum of this series. So what pieces of information do I have about this series, 4 minus 12 plus 36 minus minus 8,748? Okay, so I have the first term is, and the last term is, what's the last term?
-8,748.
Okay, what else do I have? I have the common ratio. What is the common ratio? -3. So then I can use the S of n formula, which is R times T of n minus A divided by R minus 1. So that would be -3 times -8,748 minus 4 divided by -3 minus 1. So what did you get?
-6,560.
That would be correct. Okay, so let's look at class example number 4. The sum of a certain number of terms in a series, -2 plus 8 plus -32 plus is -104,858. What's the last term in this series? So what am I asked to find? T of n. So that implies that I'm using this formula. So if that's the formula that I'm going to use, I need to identify these other variables. So what would S of n be?
-104,800.
What is my common ratio? Negative 4. And what's my first term? So I get negative 104,858 equals negative 2 times t of n. Or sorry, not negative 2, negative 4. Negative 4 times t of n minus a negative 2 over negative 4 minus 1. So what is negative 4 minus 1? Negative 5. So then I'm going to take this negative 5 and multiply it by this negative 104,858. And this minus negative 2 I'm going to rewrite as a plus 2. So when I multiply by negative 5, I get 524,290, I think. Yep. Now to get t of n by itself, I have to take 2 away from each side. So I get 288. And then divide by negative 4. So if I take that number and divide it by negative 4, what do I get? 772. That would be the last term in my series. Okay, if I look at class example number 5, in a geometric series, the 5th term, so t of 5 is 1,024, and the common ratio is 4. Find the sum of the first 7 terms. So it's s of 7. So if I was to find s of 7, that would be using that formula a times r to the power of n. I don't remember the formula anymore. Minus 1. Need brackets there. That would be the formula that I could use if I knew what a was. Can I figure out what a is? I could go back to my t of n formula. The 5th term is 1,024, and the common ratio is 4. So this is what I get when I substitute those values into the equation. N is equal to 5 because it's the 5th term. So I get 1,024 equals a times 4 to the power of 4. What is 4 to the power of 4? 256. So if I divide both sides by 256, what do I get? Yep. So if I plug that into the equation, I get 4 times 4 to the power of 7 minus 1 divided by 4 minus 1. Do you guys agree? 21,844? Yep. Okay, so I'm going to give you some of these questions to practice on before we go into the next part. Question 1, A and E, 2B, and then 3, 5, 7, and 9.